In today's video, we are going to see how to predict the number of peaks for a given molecule in carbon NMR. And we are going to do so using the symmetry of the molecule. What happens if the molecule has no symmetry? Well, then it's very easy. The number of carbons is the number of peaks, same thing. For example, propanoic acid, you have no symmetry in this molecule, and therefore 3 peaks. Or if you have this ester functional group, the ester functional group is not symmetrical, and therefore the molecule is not symmetrical, and you get 5 peaks. But if the molecule has symmetry, then the carbons which are on either side of the line of symmetry will be equivalent. They will give you the same peak. For example, when we have ethane, there's a clear line of symmetry, and therefore these 2 carbons will give you the same peak. So you only get 1. If you have propane, which we can see more clearly down here, you also have a line of symmetry. Now, this is really important. The carbons which are on either side of the line of symmetry will give you the same peak. So we could say, if this carbon gives you, let's say, peak 1, then this one will also give you peak 1. But the carbon in the middle, that will give you a different peak, which is going to be peak 2. And therefore you get 2 peaks in that molecule. Yeah. So when the line of symmetry goes through a carbon, that carbon will be unique. It will give you 1 peak. But when the carbons are on either side of the line of symmetry, then is when they are going to be equivalent. Okay, this one. So again, we have a line of symmetry there. Therefore, this carbon here, this peak, let's call it 1, will be the same as this one. Those 2 carbons give you 1 peak. These 2 carbons give you 1 peak. This carbon here is unique, gives you another peak. This carbon here gives you another one, and another one. So you have 5 peaks. Perfect. So what about this one? Well, this molecule, you have partial symmetry. You have a little bit of symmetry for the ring. So then, let's say that this carbon gives you 1 peak. This carbon gives you another, 3, 4. Then this one, again, is going to be 2 and 3. And then this carbon is going to be 5 and 6 peaks. Yeah. If you have questions that you want to ask, you are welcome to do so. Now, what happens when in the ring you put a chlorine like this one? Well, then the line of symmetry disappears, because for the ring to be symmetrical, you would need a chlorine here, which is not there. So goodbye to the line of symmetry, and therefore how many peaks? 6 from the ring, plus 1 here, plus 1 there. That will give you 8 peaks. Your turn. You want to pause the video and give it a go? Okay, I'm going to do it. So we are going to start from the left. This carbon will give you 1 peak. 2, 3, 4, 2, 3, and then 5, and then 6. And I'm going to stop here because there is another line of symmetry. And therefore, this carbon and this one, they match. So that would be carbon 5. And this one would be 4 again, and 3, and 2, and 1, 2, 3. Perfect. So I hope it makes sense and you find it useful. I'm going to leave you a quote that I think it's also really useful, so maybe you like it. And that's all from me. Bye-bye.